So welcome to this class. We are going to learn about flame photometry, and I hope you'll enjoy the lesson. So let me check who are present. We have Eric,
Present.
Josephat,
Present.
Naomi,
Present.
Chebet, and Alex Kosgei.
Present.
So welcome to this class. We can start off straight away. So we are going to look into flame photometry, and we have two objectives to cover. And as you can see, we are going to define some terms, and one of them is flame photometry and also a flame photometer. So we are going to start by defining terms, and the first term is flame photometry. Who can define to us what is flame photometry? Josephat?
Okay, flame photometry is more accurate. Okay, for flame photometry is more accurate called flame atomic emission spectroscopy. Okay, this is a branch that uses species examiners, the spectrometer.
So that is correct, because flame photometry is all about the atomic emission spectroscopy, and majorly flame photometry deals with emission spectroscopy. Then we have another term, a flame photometer. Who can define to us a flame photometer? Naomi?
It is an instrument used in organic chemical analysis to determine the concentration of certain metal ions.
So that is correct, because for flame photometry you have to use a flame photometer. So it is an instrument used to determine the concentration of metal ions in a sample. Then we have another term, group 1 element. Who can define to us what is a group 1 element? Eric?
These are alkali metals and they are elements which fall on the first group of the periodic table.
So that is true. We have examples of lithium, sodium, potassium, and cesium. Those are group 1 elements. And also we have group 2 elements. Who can tell us what are group 2 elements? Naomi?
They are also called alkaline earth metals. They are metals which fall into the second group of the periodic table. They include beryllium, magnesium, calcium, and strontium.
So that is very correct. So we have group 1 and group 2 elements, and we know that majorly group 1 and group 2 elements are analyzed by a flame photometer. So it is easy for you to identify the amount and the presence of a group 1 or group 2 element present in a sample if you use a flame photometer. So we know that there is a basic principle upon which atomic spectroscopy work is based on, that is, matter absorbs light at the same wavelength at which it emits. So this is why they use a flame photometer to see the concentration or the if a metal is present in a sample. So from there we are going to look into the properties of group 1 and group 2 elements in relation to flame photometry. So what are some of the properties of group 1 and group 2 elements that you know, class? Naomi? Are you there, class? Yes, Eric?
Sorry.
They have high melting point and boiling point.
Yes.
They have high melting point and boiling point.
True, they have high boiling and melting point because most of the group 1 and group 2 elements, they are solid in nature, and probably they'll have higher melting points. Another property, Josephat.
Okay, group one and group two elements, most of them will burn to produce different colors.
So of course we know that when you have a sample, let's say you have a sample of sodium, when you burn in a flame, it will produce a certain color. So in this specific area, we are going to look into two properties, that is ionization energy and flame test. These are the ones that we'll majorly discuss, that the one that they are related to flame photometry. So we are going to start by flame test, and we know that different elements, mostly alkaline and alkali metals, they impart characteristic color to an oxidizing flame. And this means that when you burn maybe sodium metal in a flame, it will produce a certain color. When you take another element like potassium, it will have a different color. And because of that, we can use that property, specific property, to test for their presence in a sample. So we have a chart here, and I want us to go through the chart. We have an element, we have emitted wavelength, and we have the flame color. So you see that sodium, it has a wavelength of 589, and what is the flame color, class?
Yellow.
Yellow.
So we have yellow, then we have potassium at 766 nanometer, it is violet. What about lithium? What is the flame color of lithium, Chebet?
Red.
So we have lithium. When you burn lithium in an oxidizing flame, it will produce a red flame. Then we have another property which we are going to look into, is the ionization energy. What do you understand by the term ionization energy? Mudhoni?
It is the amount of energy that is used when breaking a bond.
Okay, Mudhoni is talking of amount of energy required when breaking a bond. A nice trial. Any other trial? Eric?
Okay, ionization energy is actually the minimum amount of energy that is required to remove an electron from the outermost energy level of an element when it is in the gaseous state.
So very correct. We know that ionization energy is the minimum amount of energy required to remove an electron from the outermost energy level of an atom in gaseous state. And for us to study group 1 and group 2 elements in relation to flame photometry, we know that these elements, like in case of group 1, they have just one electron in the outermost energy level. So you don't require so much energy to remove an electron in group 1 or group 2 element. So that is why when you introduce a group 1 or group 2 element into an oxidizing flame, the outermost electron will jump from the neutral or the ground energy state to a higher energy state. And when this happens, we have absorption and emission. So in the process, we know that when an electron jumps from a low energy state to a higher energy state, at some point it will fall back, and during the falling back, that is where it emits some radiation. So as you can see from my screen, this is what happened. That is where the excitation from ground state to the excited state. But since these electrons are not very stable in the higher energy state, they fall back. During the process, they emit radiation. So that emitted radiation is what now the flame photometer is able to measure. So having these two properties, the flame color, you can tell which element is that, and having the intensity of the emission, you can tell how much is in a given sample. So I want us to look into this diagram here. This is a digital flame photometer, as you can see, and it's used for flame photometry. And going back to our slides, we can see how everything happens, just moving from the ground state to the upper energy state, then falling back. Now class, I want you to tell us what you have learned today. So we can start by defining group 1 element. What is group 1 element? Naomi? Naomi? Eric?
These are alkali metals that are placed in the first group of the periodic table.
True, so they are the elements placed in the first group of the periodic table. What are some of the examples of group 1 elements? Naomi?
Sodium, potassium, lithium, and cesium.
Okay, so we have sodium, potassium, lithium, and cesium. So another question, we have looked into the properties that are related with the flame photometry. What are some of these properties that you have talked about? Josephat?
Okay, we have talked about the ionization energy and the flame test.
So what can you tell of the flame flame test? Naomi?
Each element has its specific color when it burns. So that is used to distinguish, to know that atom,
So
the
correct,
element.
we have group 1 elements and group 2 elements. They impart characteristic color on the flame, so they each of them produce a different color from the other one. What about the other property, Eric?
We've learned about ionization energy, which is the minimum energy that is required to remove an electron from the outermost energy level of an atom from it when it's in its gaseous state.
Correct. So that is the end of our lesson, and before we leave, I have an assignment for you where you're going to describe the basic component of a flame photometer. I've shown you the image of a flame photometer, and you can discuss the basic component of a flame photometer. So let us meet in the next class. Have a nice evening.
And you too.
Thank you.
Welcome.